Okay, this video is about water and the water issues that we have in not only California but the world, especially related to agriculture. Because agriculture uses about 80% of all water consumption regionally. So let's talk about these dynamics. A typical crop takes about 48 acre inches to grow. 48 acre inches is basically, think of a football field from end zone to end zone. All that grass area, that's 1 acre. And an acre inch is how much water covers that whole area with 1 acre, with 1 inch of water. But 48 acres is about this tall, which is, that's how much water is needed to grow a crop. Basically anywhere in the world. It could go up high as 66, it can go down to 35, but let's just kind of average it out at 48. And that's water's not all applied at one time. It's applied throughout the year to get that crop to produce. And that crop could be anything from almonds, peaches, oranges. It could be cotton. So it's more of the annual type crops where it's going to take a full season. So just think of that 48 acre inches. Now, California just came out with a really interesting law called Sustainable Groundwater Management Act. And the whole idea with that is we're racing to the bottom. And they said, hey, listen, we can't race to the bottom because then our whole agricultural industry will collapse. So we're going to set some rules, and we're going to let the regional areas set the rules of what the groundwater level should be at and what's sustainable. And what sustainable means is that the natural rainwater that falls on the ground and recharges the groundwater, well, you have the groundwater here. In the wintertime, that groundwater level goes up because it gets refilled by the winter rains. And then we pump it out. But the problem is we pump it out too far. So we have to come to where it fills up and it pumps back to the same level, that whole level. And that throughout the valley goes from 6.5 acre inches to 10 acre inches. So that ebbing flow is sustainable. And not only is that sustainable in California, but that's what would be sustainable anywhere in the world. So, and since we're doing all this science research in California, we foresee that it's going to be applied throughout the world to become sustainable in all of our agricultural regions. Otherwise, we collapse. The ag areas collapse, there's starvation, and all the other bad things that happen when you don't have a food source. So 48 acre inches, 10 acre inches, let's say, is the sustainable level. So we're short 38 inches. Well, this 38 inches in the past would be made up from either overpumping the groundwater or conveyance. That's where we divert water from a river, and you see the water in the irrigation canals, and so that's where that 38 acres comes from. You hear about zero allocation. That means that there's zero amount of water flowing to serve this 38 acre inches. So that's where the big problem comes in, because now a farmer has to grow a crop that requires 48 acres, but only 10. So we have a problem. And just to make this a little bit easier, I'm going to change these numbers around a bit. And I'm going to put 50, we'll put 40. So what's happening here now is that, write this a little bit better. That means I have to retire 4/5 of my land to grow 1/5 of my land. And if I have 100 acres, that means I have to retire 80 acres to grow 20. So you can see the dynamics here. It's starting to change dramatically. If I own the land as a farmer, I could possibly make this happen. If I have a mortgage, well, my mortgage is based off of me producing off of this 100 acres, not off of 20 acres. So you can start seeing the problem here. And for just put in perspective, if I own a apartment complex and I have 100 units, that means I can only rent 20 of them because the other 80, I don't have enough water for the showers. So you can start to see where the cap rate and the return on investment just goes wild. It can't happen. We're leading to bankruptcy scenarios for farms that have, big mortgages across there. So, what's the benefit? Well, the benefit is that this 20 acres, it becomes sustainable for multiple generations. So, there is a benefit to it that land will be able to pass down from one generation to the next generation and know you'll be able to produce crops on it. And that's important because we're starting to see the capital markets, the stock market, interested in climate change and about sustainability. And this becomes fully sustainable. And it's the term that we use is called ESG. ESG. And ESG stands for environmental social governance. And it's a way to measure these three aspects: the environmental aspect, the sustainability, the social, how you treat your workers, and the governance, how do you manage your business. And when you get down to sustainable groundwater, you become environmentally sustainable. So the croplands that start to adopt sustainable groundwater will have high ESG numbers, high E numbers. The sustainable or the social aspect is the way you treat your workers. And in California, where I'm talking from right now, is that they have very strict rules in labor and the way you use pesticides and herbicides and fertilizer and everything else. So by default, crops coming out of California are going to have high ESG numbers to them, high ESG metrics. That means that if I'm a McDonald's or if I'm a Chipotle or any food products I need that come in, if I'm contracting with California farmers that are following under all these different, really strict rules, I'm going to have sustainable agricultural inputs. If I'm buying from India or someplace else that's just racing to the bottom of the aquifer, if I'm buying cotton or something like that, well, that's gonna be bad ESG numbers. And so you can start to see how these ESGs and the whole dynamic start to play into the stock market and what the valuation is going to be. Because in the past, they would be able to value a company by how much of a market share they had and how well they were marketing. But with climate change, that throws it all out the window. But ESG allows brokers and analysts to understand the dynamics of agricultural inputs into a company and if it's going to be sustainable. Not only agricultural inputs, but anything. I mean, they're measuring everything across the board: flood risk, drought risk, things like that. So the good news is that as regions start to adopt sustainable groundwaters, then those crops are going to be sustainable for multiple generations, and those agricultural inputs will be able to feed into industry, if it's cotton shirts or food products, for multiple generations. Now, where do we come in? Umida. And what's our play in all this? Well, it just happens we have the technology to grow crops with the 10-acre inches. This right here. It sounds crazy, and it's never been done before, but that's our technology. That's our moat, that we can grow crops with 10-acre inches or less. And that means that if I'm a farmer and I had to retire 80 acres of my land to grow that 20, I can now put my full production back into play with Umida's technology. Or if there's opportunities to buy land that is not being managed properly, and then we upgrade it, just like you'd buy an apartment complex and upgrade it, then we can take land that was only worth 20 acres and also start to produce 100 acres off of it. So that's us, Umida.